Thank you for making it out. Thank you for coming out to the conference. Thank you for making it out to this talk. Y'all have choices to make when you choose your breakout sessions. I hope I don't waste your time here. So we're going to go over an introduction of the Python API that's available in Salt. I'll show you a brief introduction. We're going to scratch the surface here today, show you what's possible. We'll show you some things that we've done and point you in the right direction to see if you can use it to solve some of your niche cases. And my name is Drew Malone. I'm here with Optiv Security. So top down, we're going to repeat my battle cry I've been saying, at least publicly, for the last 2 years, that Salt is not configuration management. We'll go over that just briefly. Give a couple of advantages of why bother with the API, why not just shell out and just be done with it. Do some easy comparisons. What happens when I fire a test.ping on the command line, and how can we reproduce that in Python? And we'll do that with a couple of other use cases to make sure we all understand we're all on the same page. The power of being able to examine the return data so that we can make smart choices. And after a little bit of a demo, we'll go over some of what's available in the Enterprise API. If you've been listening to any of the material, any of the keynote talks, Enterprise API is turning out to be a real good value-added product. And along with it, it comes its own set of API that you can use to even further coordinate and orchestrate your systems. And I'll wrap it up with the implications of what all of this means, automation as it applies to security, combined with what everybody's talking about, the skills shortage and going into the future, what it means for you, what it means for all of us. So according to this slide I pulled from a previous talk, for at least 2 years I've been saying Salt is not configuration management. Salt is a remote execution engine upon which you can build really cool capabilities. One of them just happens to be configuration management. If you come across someone that says Salt has lost the configuration management battle, everyone is moving on, they're missing the point. They don't realize that it's not a config management tool. You can build a lot of really neat capabilities with this. So the Python API. Why do I need to learn another set of APIs to get my job done? Can't I just do this in Bash? Can't I just use Jinja? Jinja is the default templating language in this. Yes, you could. You want to reach into the Python API when you develop very specific niche use cases. And as it turns out, what I've learned over the years is every job is a custom job. So every case is going to be a niche case. So there are plenty of opportunities to make good use of this Python API to get the job done. And like I had mentioned earlier, Bash is wonderful in its portability and its simplicity, but it's still limited compared to the full power of the Python programming language. And Jinja, for anybody who's tried to do anything more complex than some simple for loops and rendering in Jinja, it is an absolute nightmare if you try to do any complex logic. And it's pigeonholing Jinja anyway. It's a templating language. It's not meant to handle heavy logic. And just as a final reminder, and again, it's not just config management. Salt is extremely hackable. It's written in Python, so if you want to go straight to the source, you can do that, but it's also extendable very easily. It's trivial to begin writing your own modules, your own plugins, write your own states. It's very easy to get started on that. So we're going to go ahead and compare our test.ping with what it looks like in the Python API. On the left-hand side, we've got our usual targeting all of our machines. We're going to do a test.ping, and we see our return data come back to us in the form of some handy YAML-formatted CLI output. And over on the right-hand side is going to be the bare minimum of what it takes to do that in Python. So you grab yourself a client, and if you go to the docs on this material, this is basically stolen straight from the docs, how to get started. There's a number of different clients you can get. Everything that we're going to be dealing with here is going to be called the local client. 99% of your use cases are going to be with the local client. So on the right-hand side, you see we come up, and you can see the normal. Your first parameter is going to be the set of targets that are going to receive the job. The next part is going to be the functions that they need to run. And the last one is optional, but I always use it because it standardizes the return data. Full return says, give me back some metadata about the job. And that gives us a little bit of predictability and consistency about the return data, which is going to be important, as we'll go over in just a minute. So this is that return data. If you remember the handy formatted CLI output that we saw just on the previous slide, it was we had minion name and true. This is what it looks like under the hood. It's just a Python dict under the hood. We've got a job ID, whether it was a success or a failure, a return code, fairly simple. And the one thing I want to point out, we at Optiv are more of a services company. So we try to take care of other customers, data centers, and deployments. And we run into a lot of customers that are still allergic to long-running agents on their machines. So a lot of them are going to insist on an SSH-based transport. Everything you see here today can absolutely be done with the SSH transport as well. You're not limited to just minion-based deployments. And with the latest major release of SALT 2018-3 is a new master option called Enable SSH Minions, which again further homogenizes the return data you're going to get back when you do this. The demo that I have today and the code we wrote that before we were aware of that. So there's already room for improvement in what you're going to see here today. So a test.ping is always fun. It's practically guaranteed success. And it doesn't make for a very interesting topic to talk about. So what happens when things break? That's what we actually care about, because we need to be able to respond to some system or some process failing and breaking somewhere. So if you see here, I went ahead and in the example, we shut off 2 of the minions and ran our test.ping again. And this is the return data that came back from that. And the discerning eye will immediately see we don't have a standard format for our return data. Our successful test.ping came back with a valid Python dict, full with job ID, return code, etc. The 2 minions that failed is just a plain old Boolean false. So this is the first landmine that you're going to run across when you start to get into here. It's just part of the learning curve. Once you understand it and you're able to walk around it, and we're going to go over a couple of other mitigation strategies for it, it's a minor bump on the road to success here. Again, test.pings, even when they fail, are kind of boring. Let's talk about doing some real heavy work. What does a state run look like? So as a quick refresher, here's us going back out to the CLI. We're going to run a state.sls. We've fabricated a simple SLS file that's going to take care of some configs for HA proxy for us. Hopefully this is very familiar to everybody here. So what does that look like when we implement that in Python? So for simplicity, again, the first argument is going to be the target. We've just got one machine there. This time, instead of a test.ping, it's going to be a state.sls. And our third argument is going to be the arguments that apply to our function. One thing you'll notice here is the state HA proxy update configs is a list of size 1. Fun fact, state.sls actually takes as input a list of state files to run. It's just that 9 times out of 10, we're only giving it a single state file, and that's just created and converted into a list of size 1 under the hood. And again, we're specifying full return because we like predictable return data. And just to show that we're not limited to simple calls, this is that same exact state call, but we're changing up the way that we target. We're using a list instead. So we have our first line is just a list of the nodes that we care about, and we're supplying the additional argument target type equal list. This is exactly like saying -l out on the command line. And we can also specify inline pillar values as well under the keyword args parameter. So again, anything that you can imagine yourself doing on the CLI, you can 100% do by using the Python API. Okay, fine. So again, failure. What does failure look like? Here's what failure looks like for state runs. So we have a single minion with our state run. We broke it deliberately so we can get some decent return data. And we have a failure, but instead of a simple Boolean false, we still get back a valid Python dict object. So this is, again, one of those landmines. And as a gentle reminder, you see at the bottom, Test.ping just brings back a simple Boolean false, whereas a state run, you still get back a full Python dict. So understanding what you're going to get back and getting that reliable return data is key to understanding how this works. So this is where everyone in the room is starting to get a little despondent. I came here to learn how to accomplish things, and now I learn I'm going to have to build all these abstraction layers over getting around the shortcomings of the return data. Not the case. It turns out that Salt the product also has a vested interest in understanding whether their state run succeeded or not. So they've already done this for you. So built into the library already is a state checker that you can pass along. And I'm just going to give the room 10 seconds of silence and just let everyone gloss over this code to get a feel for what that looks like. So what's going on here is we do a call, we get back our list of return data objects, and then we enumerate over each one of those objects. So we take that return data that's inside that minion Python dict, and we just hand it off to this library that we don't have to write or maintain, we just use it. And we get back failed or succeeded, and that's it. Super easy. So just knowing that a state succeeded or failed is very rarely going to be enough. We need to know why it failed. We need to be able to see, was there a render failure? Did I forget to update a config file somewhere? Is the minion totally offline? A binary success or failure isn't helpful. We need more details. So how do we find out more details? So in short, the details lie in writing your own logic to inspect the return data and taking the appropriate action to see what went wrong. So the best way that I can illustrate this for you is by using the code that we have. And we have this, we've got the slides, and all of the code you'll see here today is up in a GitHub repo. The last slide is going to contain a link to it. So that demo is going to show off these capabilities of being able to respond to a failure. In this case, we have a few HA proxy nodes, all of them with their configurations. We're going to go ahead and reach out to them, and we're going to update them with their configs. And every time we update the configs, we're going to go ahead and restart HA proxy. This is on a rolling basis. So we're going to start with one node, update the configs on that, restart it, and we're going to check to make sure, is it okay? Did I break the configuration somewhere? Is HA proxy alive? HA proxy is alive. Cool. We can move on to the next node now. This is in stark contrast to just a simple blast of all of my HA proxy nodes at once, update your configs and restart, which for anything other than a simple development environment is just asking for a long day. So just to show it in action here, here's us grabbing that client, and we're taking our target nodes. We're saying state.sls, and the state file that we're going to run is going to be HA proxy update configs. Which is just a simple file.manage. We're just going to slap down a file under etc HA proxy to config. We're going to glance at the source just for a second to get some context. So this is the stanza under HA proxy that's important. You don't need to understand HA proxy to understand this demo. You just need to understand that we have some ginger right here that's reaching into pillar to pull out some files. So what does that look like? So you'll see over here we're reaching into HA proxy. Here's our HA proxy, keying into our backend static key, that's over here, and pulling out the balance figure. So everything inside this Jinja expression is going to render out to say we want a balance method of round robin. So what's happening now is we're doing a quick ping right now. Well, it's already done. The very first thing we do is we take our list of minions and ping them all to make sure that this is actually going to work. If they're offline, this is already guaranteed to fail. The next thing we'll move on to is, So we start the work on our minions. So we've got two minions here, SSE2 and SSE3. So under the hood, we're sorting it for easier tracking. And we start the work on SSE2. And we go ahead and run that update HA proxy config. We restart HA proxy. And I'm not going to bore you by trudging you through the code itself, but in that Python script is the logic that runs another salt call that says service.status on HA proxy. And we're examining the return data there to say, was it good? Was it a failure? It was good? Okay, sweet, let's keep going. So once we know that we're safe and we've not damaged our first HA proxy node, we can move on to the next one. And the process repeats until we're all done. And because we like to measure everything, we give ourselves a little time figure of how long this whole process took. So this little script was born out of necessity. We had a customer with a 200-node Elasticsearch cluster, and Elastic was talking about how they support rolling upgrades, zero downtime, in-place rolling upgrades of Elasticsearch. The problem is you have to do the work for it. There's no easy thing. What they mean to say is if you take one node out, if you drain it, if you upgrade it, and then you put it back in the cluster and join it to the cluster and turn it back on, Elasticsearch won't break. That's the only thing they actually said. The rolling upgrade is your problem to solve. So the first time that we did this upgrade, this script did not exist. We all went home at about 2:30 in the morning. It was terrible. We missed nodes. It was a salted environment, and we missed a few machines. We had some machines that were upgraded to the latest, and then the next day, after we each had 3 cups of coffee, we had to circle back and go and hit the ones that we totally forgot. So lots of time lost, lots of manual labor, even automated with Salt. We had the entire process of upgrading Elasticsearch as automated through Salt states, but the orchestration part just wasn't there. We weren't using it properly. So once we had this done, this turned that process into run it, babysit it for about 30 minutes and make sure nothing breaks, and then everybody goes home. We check on it in the morning. We made a point to make sure that we were tracking this time accurately because this goes up to, because there's so much data and it takes so long to drain a node in this cluster, this was taking upwards of 14 hours plus for a successful full upgrade. So once we got that out of the way, so we solved the Elasticsearch problem, right? Like I said, every problem is a custom problem. But we realized that the level of work involved to tear down a node, conduct the upgrade, and put him back in, you can do a good number of other things to that node while he's there. Like, for instance, patch all the packages on there. And since he's offline anyway, if you get a kernel update, you're going to have to bounce the machine anyway. So why don't we try doing that? So I'm not going to torture you by doing that here, but we extended this to add in a few capabilities now. And now we're at the point, this is used at several customer sites around, and several times the customers have said, we want to be responsible for the security patching and implementation. We want to own that and make sure we do it right. And after a couple of months and a couple of iterations and torturing themselves, they realize that it's just not, they don't want to do it anymore, and they throw it back to us. So now, once a month, we got a guy, he starts this process at about maybe 6 or 7 in the morning, not on the 200 node. It's a smaller cluster for this situation, but we're guaranteed it's about a 30-minute process now, and we're guaranteed everything is patched up to date. We don't have to worry about being out of date, being vulnerable to any of the 0 days. We're running the latest kernel upgrades. It's great, and we don't have to do anything. We just run a simple incantation. So that was a quick demo of what's available in the Salt Open Python API. I wanted to take a second. If we go back here for just another second, you'll see there's a lot of noise going on here. If and when you try this out on your system, if you're just running Salt Open, you'll see a lot less noise. This noise is generated by the instance of Salt Enterprise that's running on this VM. So why bother with Salt Enterprise? We've got so much cool stuff available in Open. Where's the value added for enterprise? So we'll go over that right now. All of the cool web interface capabilities that you've seen are just clients to the enterprise API. So now With the enterprise API being exposed to you, any cool thing that's been implemented in the web UI, you can do yourself. And even more, you can extend that functionality. The first one that we're going to go over here, so I'll back it up just a second. This is the equivalent of getting yourself an instance of the local client. So this is how we get started. Since we're running enterprise, we do need to authenticate. And this is totally, definitely a dev system, so we're saying validate cert is false. We definitely don't do that in prod, right? Right. So the script that you just watched queries an Elasticsearch master to get a list of nodes. Well, the production version that I had to sanitize, we queried an Elasticsearch node master to get all of our minions. If you have the enterprise API available, you are your own source of truth. You can easily fetch a list of all of the minions in your deployment, and you can get what their status is. Are they up? Are they not? How long have they been alive? A lot of larger enterprise environments are successfully using multi-master setups. So you can also understand what minions are tied to what master. Again, one of the key benefits of a properly salted deployment is understanding what your ecosystem looks like. And a big part of that is knowing which master is this minion reporting to. So one of the simple use cases, get yourself a list of minions. My number one favorite use case for the enterprise API is the job cache. More than once, we have had this same poor customer with 200 nodes. It's only the Elasticsearch cluster that's 200. There's another 300 nodes that are for a related project. So we're running commands against 500 plus machines. And they'll often say, how do I know that that succeeded? Because they just see a bunch of green text screen by on the command prompt. And there's no way, except for writing your own custom returner or configuring a database and using one of the stock returners. There's no way for knowing for sure if that actually works. With enterprise, you get that after having paid for enterprise for free. In the UI, you can navigate the job cache. You can see the exact return data. The UI does an excellent job of presenting it. Tragically, I don't have that here in this deck, but it makes it very easy to explore the job cache and triage your deployments and see if any runs failed. You can find out why. And under the hood, this is what's happening. This is what's being interrogated and read through. These are the data structures that push forward that UI. So ultimately, what does all this mean? What does it mean to be automating something mundane like kernel patching, something mundane like updating packages, or something terrifying like upgrading a package of Elasticsearch on hundreds of data nodes? It means you get more control over your environment. And with the Python API, you can program that control. You don't have to babysit it, and you don't need a human to intervene if something goes wrong. With a sufficiently coded logic, you can make it back off in the event of failure, which is, I didn't have time in the demo here for, but there's the logic is there in the script if you feel like looking through it. If a failure is detected on the salt run, it tries it one more time just because sometimes things happen. So we've got a couple of back off tries, but after we've exhausted the number of retries, we log everything, we back off, and we wait for a human. If you were aggressive, you could say, I understand that the return data contains this particular content. That means it's solvable by a machine. Update to the latest code out on the minion or fix the configuration and rerun. Whatever it is, if you can program it in Python, you can put it into this framework. And of course, it also means less guesswork. Like we've gone over with the Enterprise API, understanding all of your minions, their statuses, being able to find out why things failed. Easier security. One of my favorite things is if you make the hard thing, if you make it easy to do the right thing, people are going to do the right thing. So to me, and to you too, I hope, doing the right thing involves staying up to date on patches. Something that, if I'm remembering properly, the keynote that we all just came from, they mentioned upwards of 70% of our time is spent doing mundane things, updating packages, patches, kernel, reboot machines. It's drudgery. We're all better than that. So make it easy to do the right thing, and the right thing gets done more often. So to step away from the technical details of this for just a few moments, what exactly does all of this mean? We all know that everything is becoming more automated. We are that automation. If you're here in this room and you don't understand the reality that everything is becoming more automated, I would question your motivation for being here with us today. Please speak to me after the talk. And more, security is becoming more and more important. No one wants to be on the front page of the New York Times. No one wants to be sitting there in the annals of history next to Equifax for having good, healthy security measures. Nobody wants that. So put together, automation and security are here to stay and are the only way out of this mess. They're the only way forward. So we ran a quick Google search on cybersecurity skills shortage. And really, this is just repeating what, again, we just heard in the keynote. There is a skills shortage. Not only is there a tech skills shortage, there is a security skills shortage. So we have niche skills inside niche skills are becoming harder to get to. So like they had said, we're not hiring our way out of this problem. We have to automate our way out of this problem. We're constantly being asked to do more with less. We can grouse about it all day long, or we can accept it as the reality and start making things work. Like the story I was telling earlier. The first time we upgraded that cluster, we all went home at 2:30 in the morning. The second time we upgraded that cluster, we all went home before sunset, and we all had a great night's sleep. We just reduced by a large amount, in this case, the amount of human time needed to get things done. This is what they mean when they say, do more with less. We're able to do way more in this case with less humans, less time, less hours. It works out great. So just ask yourself this question. In this time of an increasingly scarce skill that we all have, do you think it's important that we have reduced the amount of human interaction needed to get something done? I'm not expecting an answer right now. It's just something to ponder while you're here. So the punchline is, whether you realize it or not, whether you like it or not, you are security going forward. Security is no longer a siloed division of the organization. It is no longer the security team, the security person. It's not going to be the CISO going forward. It's all of us. We're all on the front lines. Everything is moving outward, out of data centers, towards edge technologies, into IoT frameworks. This is the new reality. Security is everywhere. So to ask yourself a second question, who's patching your cluster this month? And how much time is it going to take them to do it? Are they going to spend a half a day to do it? Is it going to take them a couple of days? Is there a real risk of them breaking production because they're just trying to maintain a healthy security posture? Again, when you make it easy to do the right thing tends to get done. So to give a couple of parting thoughts, to give enough time for any possible Q&A, I want to reiterate, SALT is not configuration management. SALT is a platform, and you can build some really cool stuff on top of it. The next one is you're going to have to start to find more and more things to automate. And I really hope that this Python API intro has given you some inspiration to find some hooks to start solving some of your own problems. I think you'll be really satisfied, really happy when you start solving these problems, and it turns something that was once drudgery into something that's trivial. And the last part that I want to leave y'all with is you and me and all of us, we're all the future of security automation. So we might as well try our best to make it work. Thanks again for coming here. Thanks again for suffering through the talk. And I'm going to go ahead and just leave this up here unless we need to back up the slide a little bit if you want to take pictures, take notes. Otherwise, I'm happy to open the floor to questions and let you all enjoy a little break between now and the next talk if you want. Yes?
I guess I'll be the one that asks the obvious question when you're patching large clusters of production. What's your testing approaches, and are you automating any sort of testing as well?
Sure. So to make sure I have the question right, when we're going through and updating patches, what is the way of, how are we testing that, and how do we make sure we're not going to break something when we go to upgrade it in production? What are we doing about testing the upgrades, right? It's easy to say, but it takes a lot of work, and it's relentless automation. We've got we're not fully mature yet, but we have in-house capabilities. I can push button deploy, in this case, an Elasticsearch cluster on my laptop. We can specify the version that we need, so we can make a scaled down version of what we need on locally on our laptops or on a shared resource like on an OpenStack cluster or in a cloud somewhere. So make it easy to build a clone of production, or at least as close as you can get to it. And then from there, we've got our own mirror. We use the same utilities that we would use in production, and we go ahead and fire it against that and observe. That's actually a very good question. We have both benefited and been stung by exactly that. There have been times when we've successfully rehearsed upgrades and we found out a lot of wrinkles that would have cost us a lot of time had we not tried rehearsing it beforehand. And there's been other times, I said we're not fully mature yet. There's been other times when we didn't have that ability to reproduce production and we just declared a small outage window to hedge our bets. That's a good question, thank you. Yeah, I'm curious if you have, I'm totally open to input if you have anything you or your people do.
I'm in the same boat. Sometimes you can use, automation tools like iTest to, mimic, your installation and then throw a test against it, like your regression test. But there's no substitute for testing.
Yeah, so you use your own favorite in-house utilities to stand up your own infrastructure and do what you can to test out the states and all the automation you built. I think that's the best that we're all doing right now. In fact, I think that's even its own independent track at this conference. If not, there are several talks that go over that. I know that testing your automation is definitely a subject of interest to a lot of people. Yes?
How do you decide that you want to implement this in a Python script versus, say, writing an orchestrator? How do you make that? How do you kind of balance that and say, okay, this is the right tool for the job versus the other one?
Sure, great question. So the question is, how do you make the decision to write this in using the pure Python API versus why wouldn't you just write your own orchestrator to do something like this? The best that I can tell you is trial and error. If I can answer the question with a story, the way that we arrived at the Python API was we started out writing just simple Jinja logic to try to run these logic decisions for us. We realized that things got a little bit out of hand with Jinja, so we said, well, there's a Python interpreter. Let's try using the Python interpreter that's available. And I don't mean the Python API. I mean, instead of writing Jinja in your state files, write Python in your state files and have that just be rendered on the fly. And that turned out to be a lot more work than it's worth. So we realized that wasn't going to work either. That was a very painful experience. That wasn't just for this specific use case with the rolling upgrades. That was management of TLS certificates among the cluster. But so it was a progression. So we started out with writing our Jinja and then moving over to a different renderer. And then we eventually found ourselves just writing custom modules in Python and doing the work like that for us. So if you think that it would be simpler, if it would fit your workflow better to write an orchestrator, I would just encourage you to try it out because frankly, it's completely possible that this could have been done inside an orchestrator with no increased complexity or loss of function. And it could come down to just a preference for the team. Thank you. Yes?
I use a lot of Elasticsearch for growing. I'm interested because I've written my own state to upgrade. We have like a any of that work on?
Excellent question.
The Elasticsearch formula, not really good like cluster upgrades.
Yeah, good question. So the question is there a way we can collaborate and share our work on states for managing the Elasticsearch clusters, right? The short answer is not yet. We're going through the process right now to open source some of those for exactly the reason you just said. I did not write the Elasticsearch states that we enjoy, But the guys that did write it, we've already talked with them, and we're working through our corporate big brother to safely get that out on GitHub. I'm sorry that that's the best answer I can give you.
No, I haven't believed mine either, so.
Certainly, if you look at this script in here, you can see where it's firing a state.sls, and that's where it's using our in-house Elasticsearch states. So you could at least, maybe this can be of good use to you as a framework to build your own logic around, and you can just plug in your own state files into it. So if that's it for the questions, then thank you again. Y'all enjoyed the early break. Get a little rest between now and the next talk, because I think you're going to need it. This conference has only just started. Thank you again.